Welcome to USC Ideas and Actions, the official University of Southern California podcast. Shows are webcast live on Facebook from Studio 1A in the USC Annenberg School for Communication and Journalism.
So I'm going to start by asking you, Skip, a question. So you've been using AI, or what we call artificial intelligence and virtual reality, what we'll call today VR, as a form of therapy for quite a while. So can you tell me a little bit more about some of those research projects that you're working on and why you think that these may impact how we can study the brain?
We've been developing VR applications to address clinical purposes since around 1996, back in the Stone Age of VR, when there was a lot of vision, a lot of hype, but the technology wasn't mature. More recently, the technology has evolved, and over that period of time, we've developed applications for treating PTSD by delivering exposure therapy in VR simulations. We've tested children with attention deficit disorder in virtual classrooms. We've developed artificially intelligent virtual humans for training doctors. They serve the role as virtual patients. So I like to say it gives novice clinicians a chance to screw up a bunch with a virtual patient before they get their hands on a live one. And then we've also applied that same AI virtual human technology for helping people on the autism spectrum survive a job interview. They get to practice with virtual job interviewers under a range of conditions and develop the confidence and ability, reduce their fear for doing it in the real thing. So enough about my stuff. What about you? Tell me about how you're using VR to integrate it with games to enhance brain function.
Yeah. So one of the new projects that we have over at the Health Sciences campus, so right now we're here at UPC, is trying to build a virtual reality environment that really tests the parts of the brain that we think are impacted in Alzheimer's disease. And so one of the core areas that we know is impacted in Alzheimer's disease is called the hippocampus. And that's really critical for memory function. All sorts of memory, things like navigating the world, understanding where we are. We hear a lot about mom and dad when they get older that they are starting to lose their way home and a neighborhood that they've lived in for 30, 40 years. And so what we've tried to do, instead of taking our lovely participants and putting them out into the world, similar to what you just said, we put them in a virtual environment that's safe, that's controlled, it's in our lab setting. But once they sit on our bike, which I'll talk about in a little bit, and put on their head-mounted device, they transport into an entirely new world. We've made that environment a fun environment. It's a park setting, and the older adults get to be in a nice setting, and they get to really tap their cognitive skills of trying to find their way. So, Skip, I wanted to get back to your work. You've been working in this area for quite a while, and many of us look to you for your guidance. And so I wanted to really get your impression on how you think VR and AR is uniquely relevant to clinical work and really compared to what our existing methodologies are. So it gets at this question of what people always come back to, which is why VR?
Yeah. And it's an important question because I think in all this work, we don't try to put out the idea that we're going to virtualize everything. But where it makes sense, I think we can have real impact. Like in your project, in your example, there's so many things that are going on here that I think add value. Like you mentioned, the safety element, the ability to have a controlled stimulus environment where you can systematically manipulate the things that go on in the world, making it fun so people actually do it. That's a big thing, and that's always been a real driver, particularly in the VR rehabilitation area, because a lot of times people after a stroke or a brain injury, getting them to do sufficient trials of physical or cognitive rehab, very challenging. It's frustrating, it's boring, it's repetitive. But you do it in a VR game-like context, and all of a sudden, it's kind of fun. And you can control all the features in the environment and, systematically move, the challenge level up a little bit. Another element, too, is you can show people their performance in ways that they wouldn't see in their own behavior. So, somebody after a stroke and they can only move their hand a little bit and they're doing a rehab task, and you show them from day to day that by doing that activity, they're moving it just a little bit more each time. And that's something they wouldn't notice because there's a psychological component in all this and getting people engaged in their activities to support their health and their growth. And I think this is where, you know, the work you're doing is quite important. In our area, we've got data now to show, if, you know, for very emotionally challenging type therapy, treating PTSD, that a large majority of people seeking help, when you do it in a systematic way and you ask them what they would prefer, the traditional method or VR, 75% pick the VR. So, you know, that talks not only to the idea of clinical efficacy, which we've documented in our work, but also breaking down barriers to care, getting people to come in and actually do the hard work of therapy that they might ordinarily try to avoid.
Yeah, one point that you made that I really wanted to touch upon was the feedback that you can give in VR. So in a regular clinical type of setting, that feedback is really, can be sometimes therapist dependent, it can be type of intervention or therapy dependent, therapist dependent. And what you're stating, though, is that you can really build in direct feedback, immediate feedback, and we've shown in so much behavioral literature that that type of feedback really improves motivation and compliance and just the likelihood that one is going to complete that type of therapy. So that's such a good point with respect to VR and being able to have these controlled environments.
I think it really speaks to the issue that not only can we control what the person is exposed to or what they interact with in a very systematic way, but we can measure performance in ways that, you know, you're not going to get in a regular clinic. You know, you've got a therapist maybe working with somebody doing a physical therapy action, and they're focused on helping the person to do the behavior. They're not maybe so focused on, oh, you were able to move a little bit further each time. And I think that's important. We can quantify that. We can put it in a form that's intuitively graspable by a client. And very motivating.
It's fascinating.
So, you know, tell me a little bit about the integration of mind and body, if you will, because that's something I think VR, we talk about embodied cognition and things like that. How do you think this drives the work that you're doing?
Yeah, that's a great question. So we wanted to integrate brain and body together in an intervention. And this was very purposeful for Alzheimer's disease because we know that Alzheimer's disease is a complex, multifactorial disease. That's why it's been so hard to capture and really to be able to fit it into one magic pill. And so what we want to do is hit it on multiple risk factors. And we know that one of the risk factors is physical inactivity. Our bodies need to get up and move. We all know from just our own anecdotal evidence that when we get up and we go for a walk, we feel better, our moods are better. When we kind of increase that level and it gets to more moderate aerobic or even high intensity exercise, we really get our blood pumping. And we now really understand that what's good for the heart is good for the brain. What's good for the body is good for the brain. And so by integrating these two together, we're able to leverage the benefits of things like exercise into something that we think is also potentially very beneficial, cognitive training or cognitive stimulation. So for a while, we thought we were born with all the brain cells we'd ever have. We now know that there's a process called neurogenesis that happens, again, in this hippocampus area of the brain that's critical for memory, that actually accelerates when you exercise. So neurogenesis is an event or a process in the brain that happens just normally. But when you exercise, a lot of those positive brain events actually upregulate or increase or accelerate the growth of these new brain cells. And then the key here is the virtual environment. If we can give those new brain cells something to learn, they're more likely to integrate into a network. So this has been shown and documented in animal studies, where if the animal is in a stimulating environment versus a deprived environment, that those new neurons are more likely to grow and mature and continue on and get integrated into a network, as opposed to being absorbed back into the tissue. And so we think, well, why not combine those? And that's something that we can do in a controlled setting and with VR, really trying to impact what's happening in the body to improve brain health. And we're hoping that this is potentially something that's hitting multiple risk factors for Alzheimer's disease and really hope to continue and extend it to hit other risk factors like social engagement, and just really keeping our brains young and healthy.
I think that makes a lot of sense. I think the mind-body dualism of old school philosophy is, I think is kind of debunking that now with modern neuroscience, like understanding how the body and the mind working together in unison. Really, it's a unified package. And if you want to impact change, if you do it together, you're going to see more value. It's interesting that you're addressing the far end of the aging spectrum, and we're looking to do work similarly with children with learning disabilities, where we call it embodied cognition, and the idea is that you develop cognitive processes by physical interaction in the world. And sometimes kids with learning disabilities also have coordination problems. So if we can work on developing cognitive tasks that involve not just hitting a button or a gamepad or something, but actual real movement in the cognitive activity, we may have an impact on the early end of the lifespan. And I think that's sort of a vision that we could have across the whole lifespan, is learning by doing. It sounds so basic and simple, but it makes some sense.
Yeah, I agree. I really appreciate the work that you do on that end of the lifespan and what we're doing over on the other end of the lifespan. But really, it all goes together, because it's maintaining brain health, it's maintaining cognition, maintaining physical health as well. I agree. I think if we're navigating an environment when our bodies aren't actually having to do anything to navigate that environment, that's likely to be less effective than physically doing the movements. It's like what we oftentimes read for any type of athlete or musician. They say if you do 100 or 1,000 hours of that type of activity, that your body will really learn it. I mean, it's the muscle memory, and it's the muscle memory that feeds into brain memory, and the continual reactivation of those brain circuits that makes that type of activity become more natural and really instantiated in the brain.
Yeah. I think oftentimes you do see in brain injury that while abstract, declarative memory, as we talk about, memory for naming objects and so on, there might be some significant impairment there, but procedural skills are often preserved. You found this with the famous case HM, where he had his hippocampus removed and he couldn't remember day to day. He could remember everything from before the operation, but he couldn't remember day-to-day things. He couldn't record that memory. But if you give him a motor task, what they call the pursuit rotor task, each week they would come back with it, and he'd never remember having done it last week, but he got better at it. And that motor memory and the cognitive element of it, was preserved, even though he didn't have a conscious declarative memory of it. So there's so many fascinating areas of the brain, and I think that VR stands well poised to be able to address these things, because when back in the 90s, when VR was still sort of a harebrained scheme, and I'd go to psychology or neuroscience conferences, I'd have to spend half my time describing what VR was and why it made sense. And probably the best metaphor that helped to get that in was, would you prefer when you fly home from this conference that your pilot trained in a simulator for how to deal with wind shear, or would you prefer you learned it out of a book or on the job training? And then it becomes clear, VR, a simulation technology, we can test, train, teach, and treat human function.
Yeah, you learn by doing.
Yeah.
Great. Well, I wanted to ask you now, because you've made this wonderful statement about the use of VR in different types of clinical settings and so forth. So, based on this, when do you think that VR can really come into common clinical practice, common care? At what point will it really impact our healthcare system? And can we say a prescription, you go to the doctor and you go over to the next room and you do a series of VR treatments?
I'm not sure if I'm the best person to ask that question, because for years I've been saying, within a couple of years, this is going to be common practice. I'm the optimist on this. But I really believe now, and I can back it up with, the growing body of research, and much of it quite positive, and the reduction in the cost of the equipment and all the enabling technologies that have evolved to get us to this point where a headset like what you're using, the Vive, a headset with that capability didn't even exist 5 years ago, really, and anything that came close to it was $20,000. Now it's like $500-600. So now that the costs have come down, in the popular culture, VR is like a big thing, so people are aware of it. I think that when VR headsets become like toasters, everybody has one in their home. You might not use it every day, but everybody's got one. When everybody has a VR headset in their home for whatever purpose, to watch journalistic, stories or to do exercises or to play games, at that point, I think we'll see people kind of not just being curious about it, but kind of expecting it as part of their health care. I think it'll make intuitive sense. And I see that happening in the next couple of years.
Yeah.
The one good thing we have in our field is that we probably have the most evolved and developed scientific literature of any VR use case. People have been doing the research, even if it was primitive in the early days. They've been doing the research on how people interact in these environments. If you look at psychology as a science, it's been around 125, 150 years studying human behavior and interaction in the real world. Well, now we've got a good start on studying human behavior and interaction in the virtual world, whether it's social psychology and how people interact, or whether it's cognitive psychology, where we understand how people think about things and interact with cognitive challenges that are relevant to the real world.
Yeah,
so
that's great. So now we want to go and take any questions that we have from our audience here. Okay, so we can go ahead and read this first question. Can you explain the difference between AI and VR, and which one has more impact as a form of medicine? We'll give that question over here to Skip with his expertise.
AI, I'm not sure if the person asking the question is getting AI and AR confused. AI is artificial intelligence. AR is augmented reality, and contrasted with VR. Augmented reality is see-through glasses. It pastes graphics into your everyday
Pokemon Go.
Yeah,
Pokemon
exactly.
Go is a perfect example of AR.
Whereas VR is a contained environment. You turn your head, the graphics update, you get the illusion of being immersed within that environment. Now AI is artificial intelligence, and this is where we talk about machine learning. We talk about building algorithms that can mimic how the human brain thinks. Now, I believe that all of these technologies are different tools in the toolbox. It's like saying, what's better, a hammer or a screwdriver? Well, it depends on the task. So AI will be embedded more and more as that technology continues to improve, particularly with the virtual human work. But all these things stand well poised, I think, to advance clinical care and research.
I think another question we have is for both of us, which is how do we get involved in this type of research for our viewers, those who want to participate in research here at USC? So I'll start with mine. So my lab is over at the Health Sciences campus, and we have a few different lab spaces there and a few different studies. But if you're interested, you can always go to our lab's website, which is thepawlab.com, and you can click on Participate, or you can click on Contact Us, and we'll reach out to you. This is for our older adult population. Anybody who's 50 years and older. We really want to study from midlife all the way to late life to understand what processes are happening in the brain to maintain brain health, or those that may put us at risk for future dementia. And so go ahead and go there, or you can always email me, judypaw@usc.edu. And how about you, Skip?
Well, our lab, addresses a wide range of research questions and development processes, everything from the psychological component, cognitive, motor, and the virtual human work that leverages a lot of AI. And at the Institute for Creative Technologies, we have internship programs that run through the summer where you can apply, and it's a 12-week program, and you can actually work with the researchers at the Institute. We have a lot of projects around the community. We try to collaborate with people that are actually working in the trenches clinically. So with a group at the Long Beach VA or at Children's Hospital. in Los Angeles. Wide variety of projects and in different contexts. So if you're interested in being involved in any of this work, you can look up the Institute for Creative Technologies on the web, and my email is my last name, Rizzo, @ict.usc.edu, and I'd be happy to send you more information about the work that we're doing. We have another question. How do you see embodied VR shaping up the future? And how long before, oh, that's another question. Okay, embodied VR. Well, it's getting a lot easier to do that because we've got good sensing technology with, camera-based sensing that can track user movement, or better, inertial controls and all the different technologies that go
And
into
Skip, maybe you
interaction.
want to start with what embodied VR is for our other viewers who maybe aren't familiar with that term.
Good point. It's the idea that you're not just in a virtual environment and interacting, say, with a gamepad or a little controller in a less natural way. Now, admittedly, sometimes a less natural way may be an efficient way to interact in a virtual environment, so we don't want to write that off. But embodied VR really is about natural body movement, reaching and seeing a representation of your hands.
Because we now have technology where you can wear different sensors, and when the person reaches out into the environment, they see a hand or an arm that represents their body, and so they actually get the sensation that they're having that type of movement. Similar to some rehab types of therapies they have for phantom limb, right? To rehab and have a mirror in the middle and have them move a limb where they think it's their other limb that is disabled.
It replicates the old mirror box applications, which is still a mystery to me how that works. But, moving your preserved limb and seeing your lost limb moving for some reason reduces this pain.
Well, it shows that we can retrain the brain.
Yep.
I mean, in the absence of a physical limb, or in the absence of really our being able to see our physical arms moving and tricking the brain almost, or retraining the brain to have that sensation.
We've been doing some new work as well with a sensor we put on a headset called Elite Motion, and it actually captures your hands in real time moving and embeds it into the virtual environment. And in this way, you can do that kind of first-person reaching type rehab, but in a game-like context, as opposed to, in the past we'd use a Kinect and it captures you and you see representation of yourself on a screen, and a third-person representation. So this is an area that's hot, that's moving forward, and it's only going to get better.
Yeah.
Another question. How long before VR can help us become smarter people?
Or smarter perceivers of the world. Yeah, so smarter perceivers of the world. I think what we see visually, whether or not it's coming from our true physical environment versus what we see in a VR environment, it's still what our visual system is inputting. And so information comes in through our eyes, it goes onto our retina, it gets transduced all the way back to the back of our brain here, which is where our visual cortex is. And we create what we see. And it's really amazing the level of precision from what we see into what how it maps onto the back of our brain, where our visual cortex is. And so I don't know that VR would change that necessarily, but what I could see the viewer being interested in is potentially AR. So having, similar to Pokemon Go, so having Google glasses on, and being able to just stare out into your natural environment, but then getting reads of information about the number of people in the room, the body temperatures, similar to things that we've seen on movies, really, like Minority Report.
The classic,
we all think of that with being able to pull these screens down and manipulate data by hand. I have seen some applications of VR where they've actually done that. So the idea where the avatar in the VR environment can manipulate data that they're looking at in real world. So 3D data is really hard to visualize on 2D, on a flat 2D XY graph. Once you throw in that Z component, it gets a little bit more challenging. But I have seen it in VR, where you can come and you can turn it around and get a better appreciation of relationships between variables that we look at in research. And so, I don't know, Skip, what do you think about whether or not that would be really commonplace in our environments, where we can quickly gather in this type of information that our brain and our visual system naturally wouldn't capture.
Well, I think that the question about making people smarter comes back to, does media in general help people? I mean, books made people smarter, I believe, and I believe that films and television and podcasts and now VR, following along in a chain of technologies that give us more opportunities. And I think your point about, particularly with using AR, where you can pop up more information into your everyday context to be able to learn about it in the context, not reading a book and then going out into the world, but instead it's popping up in real time. And I think that's going to be very helpful. Now, being smarter or helping people to make decisions, those might be two different things. Like, for example, I would love to have an AR application, and I want to build this, where you walk into a mall and you're wearing your glasses and you look at a company logo, and up on the right it pops up what political campaign they donated to, did they donate to the NRA, and inform my buying decisions based on moral, ethical principles.
Yes, please
that
build
I
that app. Okay, so I think we are out of time. We're going to wrap up now, and we really want to say thank you for joining us. A really big thanks here to USC Annenberg, and here we are coming to you live from Studio A. We'll see you next time.
Thanks for listening. Subscribe to our podcast and follow us on Facebook.